Hello everyone. We were talking about cost estimation for shell and tube heat exchanger and installation column. So everybody has designed a shell and tube heat exchanger. So what is there? Look at the heat exchanger. We have the shell. There will be flange. And to this, we have this closer. I think this was where the exchanger would be. There are number of tubes. Yes. Which are welded to the flanges. Correct. Plus what we have is the baffles with the spacing. You have the whole dimension of correct. So what we have, diameter of shell with thickness, tubes, ID, OD, baffles, diameter and thickness. Yes. Flanges, and closing ends. So to estimate the cost for each of this part. Correct? Let's see how do you do it. So when you want to, let's say, talk about cylinder, how do you find out a cylinder cost? A shell diameter. So first we find out volume of shell. Yes. So how do you find out? Now this is a hollow cylinder. So for hollow cylinder, the formula is area into height or length. So what is the area? It's a hollow cylinder. So pi by 4 d outer square minus d inner square into its length. So you know ID, OD, length. You can find out volume. This is the volume, actual volume required. So mass of shell. What is the mass of shell? This volume of shell into density of material going into it. This will give you mass of shell. This is a mass of shell. Now when you make any shell, it is not going to be exact material you're using. Some material goes west. So total would be, let's say, 20% going west. So 1.2 times of this will give me total mass required for shell. Clear? Now this is just the mass of material I require. Now into, there is a mass into the cost of material. So the cost will come later. So this is a mass only of shell. There is a manufacturing cost. So 30% typically goes into manufacturing cost. So 1.3 times. So this is into a cost per kg. Correct? Based on what is the material you're using. So this become a cost into manufacturing cost, which is 30% extra. So cost of shell, which is cost of material including 20% waste into 1.5, 1.3 times. This is goes on manufacturing cost. Manufacturing. So this is basically the total cost of shell. Similarly, you have to, this is, I just demonstrated for shell. Similarly, you can find out for tubes. So we know number of tubes, find out material goes into one tube into 20% extra, find out the cost of per kg, you get total cost of material, one tube into manufacturing cost, 30%. This will give you cost of one tube and into number of tubes. Yes. Similarly, we have flanges. So appropriately, you can think of now a diameter of flange would be, now flange is a plate with a diameter equal to a diameter of shell, and we'll have a thickness of it. So it is just one flange. You can consider a vertical flange is there, circular plate with a thickness is going as one flange. So same, find out. Now this is not a hollow, this is an actual plate. So when you consider this, it would be pi by 4 d square, outer diameter of this, correct, into a length of this would be a thickness. Are you getting it? So this is a complete filled up plate with a thickness. So area would be pi by 4 d square is diameter into thickness. This become a volume of one baffle spacing plate into density of material into 1.2 times the material going into the waste, this into the cost per kg is going to give you total cost into 30% would be manufacturing cost. Your total cost of one flange. We know number of flanges, sorry, number of baffles. We can find out total cost going into baffles. So you can take, if you're using carbon steel, you can take cost to be around rupees 60 per kg. If you're using stainless steel, 304, cost would be around 225 per kg. If you're using SS316, you can take cost to be around 260 rupees per kg. So based on the material, this depends on what material is handled inside. You choose this, you will get this. Plus, we'll have this flanges, which will have holes, and these are welded. The tubes are, they are made a hole in a triangular square pitch, and every tube is welded this side and this side. So we have two thick flanges. So it will also have, similar to this, the whole material thicker than this. Yes. So you can just imagine and make a sense. This could be just total plate. This is cut, but when you cut it, this you consider the total one. Yes. So you find out this flanges. Similarly, of this, do the thickness of flanges would be higher than thickness of baffles. Take it accordingly, find out the cost of flanges. So now cost of this, plus we have incoming and outgoing nozzles. Yes. Plus we have this closing end. So incoming nozzle and closing end, this, so after you have shell cost, baffle cost, flanges cost, tube cost, everything is done, you will get a rough cost of heat exchanger every part following 20% waste cost and then 30% manufacturing cost. So this inlet, outlet, and the closing end, let's say this contribute to 30% of total cost. So whatever cost is there, the 30% extra would contribute by the closing end. This will give me a cost of shell and tube heat exchanger. All the taxes will be extra. This is a basic cost I get. Then we also consider 10 to 30% is a margin your buyer is giving you. Consider, let's say, 10 to 20% margin. So you will get what is a cost of heat exchanger the buyer should charge you, the seller should charge you. So you get a very, very good approximation of what should be the cost. Now, exactly same thing we follow for distillation column. What is there in distillation column? So if you look at the distillation column, we have this column, correct? Plus we have plates, correct? Plus we have this downcomer. Yes. Plus we have some input nozzles. Yes. There will be outlet connection, liquid vapors, which will be connected to the reboiler and condenser. So we are interested only into looking at a cost of distillation column. So I want whatever dimensions you got for your own system, use the dimension and find out cost for your own shell and tube heat exchanger and own distillation column. Thank you so much.